All right, we are moving on to section 5.2 today. This is going to be over factoring out a GCF, and we're going to look at difference of squares. These are a couple of factoring methods that will help us when we move into 5.3 and 5.4. All right, so to start, we're going to talk about a GCF, and GCF stands for greatest common factor. Greatest common factor. Okay, so that just means we're looking at what all of the terms have in common, and we're taking out everything they have in common, not just some of the things. Because it says greatest common factor, we want to take out everything they have in common. Okay, so this is going to always be our first step when we are factoring. We will look at some other factoring methods later in this unit, but we will always check for a GCF first. When we are checking for that GCF, we need to actually factor out the GCF, meaning once we find what the GCF is, we are going to divide each term by the GCF. So let's write that over here. Divide each term by the GCF. And then we're going to get some leftovers. So once we divide that out, we are trying to find what is left over after we divide it. So I'm going to write to get the leftovers. Okay, so we'll look at what that means here in the context of our first problem. Okay, so on number 1, I have two terms. I have 2x and I have minus 8 or negative 8. Since we will be dividing by that GCF, I'm going to go ahead and put lines under each term because I will divide each term by the GCF. So I see a 2 and I see an 8. Well, they're both even numbers, so they have a 2 in common. So I'm going to divide by that 2. If I look at the variables, there's only a variable on the 2. There's not a variable on the 8. So I can't take out any variables since there's not variables in every term. Okay? So if we look at this, I'm going to put the GCF here. Okay? And then I'm going to start some parentheses. And in the parentheses are where I'm going to put the leftovers. So the leftovers are what's left over when I divide by that GCF. So if I look at 2x divided by 2, I'm left with x. And if I look at negative 8 divided by 2, I'm left with negative 4. Okay? So that would be my answer, 2 parentheses x minus 4. We have factored out the GCF, that's out front. What is left over after that division is in the parentheses. A way to check your answer is we could multiply this back out. We could do our distributive property, 2 times x, 2 times negative 4, and we would get back to that original problem. All right, let's try another one. All right, so I'm going to underline each term. We're going to look for what these have in common. So I see 12 and I see 10. These are both even numbers, but I want to always check for the greatest common factor. So if I look at my factors of 12, 1 and 12, 2 and 6, 3 and 4. If I look at my factors of 10, I have 1 and 10, 2 and 5. So the only factors they have in common are the 2. If 10 was divisible by 4 or 6 or something like that, we could use one of those. But 2 is what they have in common. So we are going to use 2 on this. All right, I see x squared, but I don't see any x's on the 10. Since I don't see any x's on the 10, I cannot take any x's out. We can't take an x or a variable out of something that does not have that. So we're going to put the GCF out front. And inside the parentheses, we're going to put the leftovers. Okay, so when I actually divide this out, 12x squared divided by 2, I would get 6, but the x squared hasn't changed, so 6x squared. Then I look at my next term, 10 divided by 2, I have a 5 plus 5. So everything that is left over after you divide goes in the parentheses, and we have our final answer. All right, on number 3, I'm going to put my division bar because we need to make sure we divide by the GCF. Between the numbers 3 and 9, 3 goes into both. On this one, we will need to look at our variables. So I have x squared and I have x. I have at least one x in each term that I can divide out. I cannot take out x squared or another x because my 9x only has one x. So making sure you're only taking out what you have. You cannot take out any more than what you have, okay? So GCF out front. And then in the parentheses are going to go the leftovers. So when I divide this out, 3x squared divided by 3x, if we think about 3x squared, that's 3 times x, and then we have 3 times x, so the 3's would cancel, and one of the x's would cancel, so we're left with an x. Here, 9 divided by 3 would be 3, the x's cancel, so I'm just left with that 3. Again, you can always go check your work by distributing. 3x times x, we'd get 3x squared. 3x times 3, we'd get 9x. We can check our answer that way. All right, let's keep going. We got a few more examples with GCF. All right, dividing each term. I see 18, 8, and 2. My factors of 18 are just 1 and 18, 2 and 9, 3 and 6. Since my lowest number here is 2, we can't take anything more or anything out bigger than 2, so I will need to use my factor of 2. And then if we look at the x's or the variables, I have x squared, I have x, but then my 2 does not have an x on it, so we can't take any variables out of something that does not have an x, so our GCF is just 2. And when we divide this out, 18 divided by 2, I get 9. The x squared stays the same. Negative 8 divided by 2 would get me negative 4. The x stays the same here. And we would have 2 divided by 2. Make sure that we don't think this cancels out. 2 goes into 2 once, so we still need a plus 1 there. Okay? So really watch that you're not getting rid of terms. We have to have that placeholder there of 1. Okay? So GCF out front, leftovers in the parentheses, we have our final answer. Again, you could distribute this back out and get to your answer again. All right, number 5. Start with underlining all my terms. I have a 3, a 6, and an 18. 3 is my lowest number, so we can't go any higher than 3. But 3 will go into 6 and 3 will go into 18, so I will use that 3. And then if we look at our variables, I have an x squared, I have an x, and then 18 doesn't have any variables. Since 18 does not have any variables, we cannot take any variables out. So GCF out front. Leftovers will go in the parentheses. Okay. 3x squared divided by 3, the 3's will cancel, we're just left with the x squared. 6x divided by 3, 6 divided by 3 is 2. We have not taken away that x, so we still have 2x. And last, 18 divided by 3, we get 6, so I bring the plus 6. GCF out front, leftovers in the parentheses. You can always check your work by going back and distributing that back out. All right, last one for GCF before we move into difference of squares. All right, 2, negative 20, and 8. 2 is my lowest number. They are all even, so I can take that 2 out. And now if we look at the variables, I have n cubed, I have n squared, and I have n. We have variables in every single term, so we can take a variable out. But the 8n over here just has one n. We can't take out any more than that 1 because 8n only has 1 to take. So our GCF is 2n. That is going to go out front. Parentheses for the leftovers. All right, 2n cubed divided by 2n. Again, if it helps you to think of it all expanded out. 2 times n times n times n over 2 times n. 2's cancel and one of the n's. We're left with 2 n's, so we'd have n squared. Up here we have negative 20 divided by 2 is going to get us negative 10. We had 2 n's, we're taking 1 away, so I'm left with 1 n. And last, 8 divided by 2 is 4. The n's cancel, so I have plus 4. Again, always go check your work. If I distribute out to each term, we should get back to our original problem up here. Okay? GCF out front, leftovers in the parentheses. Okay, so we will be using GCF for the rest of this unit. That is always going to be the first thing we check in any problem. We're going to check for a GCF. Okay? All right. Another factoring method is difference of squares. So when I say squares, I'm talking about our perfect squares. So we could have our list of perfect squares of 1, which is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, 10 times 10, 100, and we could go on. But that is our list of perfect squares. That is what we will be using with difference of squares. We're looking for those perfect squares, okay? Okay, so if we have a squared minus b squared, meaning a and b are both perfect squares, we need to take the square root of each of these to find what those numbers for a and b are. So if I had like 25, I would square root 25 and I would get 5. So if a squared was 25, then a would be 5, if that makes any sense. We'll look at some examples so that'll make some more sense. But the way we do this is once we find a and b, once we square root each term, we are going to have 2 sets of parentheses. One set will be a plus b, and one will be a minus b. Okay, so off to the side here, let's write square root each term. And just a reminder, square root is that symbol. So I'll say square root each term to find a and b. All right, so the type of factoring is difference of squares. Difference means subtraction, so we had subtraction there. That's why that works, okay? If we see addition, then it's not difference of squares anymore, and it is not factorable. Meaning we cannot find those 2 sets of parentheses that would multiply out to get our original problem. So if we ever see that plus sign, it is not going to be able to be factored, not factorable. Okay, so let's try some examples here. Okay, so remember we said square root each term. So I'm going to square root x squared and I'm going to square root the 16. We are not including that negative or that subtraction sign in our square root, okay? So the square root of x squared, we are thinking about what times itself will get you x squared. Well, I know that x times itself is x squared. All right, 16, the square root of 16, what times itself equals 16? Well, 4 times itself equals 16. So that means a is going to equal x and b is going to be 4. Okay, so this is like our a squared minus our b squared. We're going to go straight into setting this up with our 2 sets of parentheses. And remember, it's a plus b and a minus b. So if a is x, I'm going to have x plus, and b is 4, x plus 4, and I would have x minus 4. Okay. If we were to multiply all this out, we would get back to that original problem of x squared minus 16. But we're looking for those 2 sets of parentheses. All right, let's try another one. I'm going to square root each term. Each of these are perfect squares. We have 4 and 81. The square root of 4 is 2. The square root of x squared is x. The square root of 81 is 9. So that means that a is 2x and b is 9. So we're setting up our 2 sets of parentheses. We have a plus b, so 2x plus 9, and a minus b, 2x minus 9. Okay, 1 plus 1 minus with what we get after we square root each term. All right, number 3 looks a little backwards. We're used to the variable first, but that does not matter. We're still going to square root each term. I see that 4. I know that 4 is a perfect square. When I do the square root of 4, I get 2. The square root of g squared, it's kind of like our x squared. The square root is x. So with g squared, the square root would be g. Don't let the actual variable itself throw you off. So that means a is 2 and b is g. We set up our 2 sets of parentheses, 1 plus and 1 minus. Still going in that same order as our problem. It doesn't matter that the 2 is first and not the variable. All right, last one. 12 and 27. Neither of these numbers are perfect squares. So I won't be able to just square root each term and get answers from there, okay? If you remember all the way back up here, the first step when factoring is to look for that GCF. So we need to see if there's anything that we can divide these terms by first, okay? So 12 and 27, if it helps, write out your little factor tables here. Those are my factors of 12, factors of 27. So the thing I see in common here is a 3. So I can divide each term by 3. I don't have any variables to take out, so remember, GCF would go out front. In the parentheses go the leftovers. 12 divided by 3, I get 4. I'm going to keep that x squared. Negative 27 divided by 3 would be negative 9. Okay. All right, so inside the parentheses, we can now do our difference of squares. We're going to keep this GCF of 3 out front the whole way through, but we're just going to go through and do our difference of squares here. Okay. So GCF stays out front. We're going to set up our 2 sets of parentheses like we did on the rest of these difference of squares problems. The square root of 4x squared would be 2x. The square root of 9 would be 3. So a is equal to 2x and b is equal to 3. So I will use those to set up my problem. 2x plus 3 and 2x minus 3. Remember, 1 plus 1 minus for difference of squares. Make sure, since we took that GCF out, that GCF stays out front. We don't just leave it off. It does have to stay there. Okay? All right, so always check for a GCF. Make a note here first, especially in this case, if you see those numbers and they are not perfect squares, most likely you have a GCF you need to take out first. All right, that is section 5.2.